So hello students, today we see about auto-oxidation reactions. So these reactions, why we are saying as auto-oxidation means there is no particular oxidizing agent is there. So just with the help of oxygen in the presence of air, the oxidation takes place. So for example, if you see some specific elements are there which undergoes which are involving in this auto-oxidation reaction or if you see the non-metals phosphorus, if you see the metals like zinc, lead, even if some compound turpentine means it's a organic compound, it's a hydrocarbon having C10H16 molecular formula. So these compounds absorb the oxygen present in the air. They easily absorb the oxygen. మన heat చేయాల్సిన అవసరం ఏం లేదు. Just in the presence of air, they absorb the oxygen of the air and they are converted into an addition compound. అంటే element మనం in the presence of air తీసుకుంటే they absorb the oxygen and forms an addition compound. ఒక addition reaction form అవుతుంది. ఇక్కడ addition compound form అవుతుంది. Okay, so addition compound ఏం చేస్తుంటే again it oxidizes the moisture present in the air into hydrogen peroxide. Okay, అంటే ఆ ఎయిర్లో ఉన్న ఆక్సిజన్ అబ్జర్వ్ చేసి itself they are oxidized. So what type of reaction? అక్కడ addition reaction అవుతుంది. Oxidation it's okay, it is addition type of reactions. మనకి some other type of chemical reactions, so replacement reaction, elimination reaction, condensation, okay, addition reactions అట్లా ఉంటాయి. జస్ట్ టూ కాంపౌండ్ యాడ్ అవుతాయి అక్కడ. సో టూ మాలిక్యూల్స్ పర్ఫెక్ట్గా యాడ్ అయిపోతే దాన్ని అడిషన్ రియాక్షన్స్ అంటాం. సో అంటే ఇక్కడ సమ్ మెటల్స్ లైక్ జింక్, లైక్ నాన్ మెటల్స్ లైక్ ఫాస్ఫరస్, కాంపౌండ్స్ లైక్ టర్పెంటైన్ ఆయిల్ అని యూజ్ చేస్తాం. ఓకే, దే అబ్జార్బ్ ద ఆక్సిజన్ ఫ్రమ్ ద ఎయిర్ అండ్ ఫార్మ్స్ అన్ అడిషన్ కాంపౌండ్. So not only these compounds, some unsaturated hydrocarbons. So what is meant by unsaturated hydrocarbons? Which are having double bond. Okay, so double bonded, triple bonded compounds, double bond between the carbon atoms, triple bond between the carbon atoms are treated as unsaturated hydrocarbons. So they absorb the oxygen from the air and they form an addition compound. So after the formation of that addition compound, again they donate that oxygen to the water, to the moisture present in the air, and oxidize that H2O into hydrogen peroxide. So this conversion of H2O into hydrogen peroxide is called auto-oxidation. Okay, for example, if you see lead, so if metal lead taken in air, it automatically absorbs oxygen of air and converted lead dioxide PbO2. This Pb plus O2 PbO2. It is called addition type of reaction. Okay, now the formed PbO2 combines with the moisture present in the air and it oxidizes this H2O into H2O2 and itself it is reduced. Okay, here H2O is oxidized to hydrogen peroxide. This conversion is called auto-oxidation. So actually in the presence of అక్కడ ఎయిర్లో పర్ఫెక్ట్ చాయిస్ ఏంటంటే H2O. ఇక్కడ H2O is oxidized to H2O2 by this lead dioxide. Okay, lead dioxide ఈ H2O2 oxidize అవ్వడానికి రెస్పాన్సిబుల్. That's why this lead dioxide here it is known as auto-oxidator. So example we are saying it, ఏదైతే ఆక్సిడైజ్ చేయడానికి యూజ్ అయ్యే కాంపౌండ్ ఉంటుందో, సో ఏ కాంపౌండ్ ఇక్కడ ఫామ్ అయింది. ఓకే, సో ఆ కాంపౌండ్ H2O హైడ్రోపెరాక్సైడ్ ఆక్సిడైజ్ అవ్వడానికి యూజ్ అయింది. దట్ ఇస్ కాల్డ్ auto-oxidator. ఓకే, auto-oxidator. సో దిస్ auto-oxidator లో సో ఎట్లా ఫామ్ అయింది యాక్చువల్గా? దిస్ auto-oxidator is formed by a starting material that is called here lead. ఈ ఎగ్జాంపుల్ lead. So this lead is called activator. Okay, this compound is known as activator. So this is called activator. సో ఇది ఆక్సిజన్ తో కంబైండ్ అయిపోయి ఒక అడిషన్ కాంపౌండ్ ఫామ్ అవుతుంది. that addition compound will oxidize as the other compound. ఇక్కడ మనం H2O ఎగ్జాంపుల్ తీసుకున్నాం. సో యాక్చువల్గా so it's auto oxidator. This H2O accept the oxygen from this and it is oxidized to hydrogen peroxide. So for example, in the place of H2O కాకుండా వేరే అదర్ కాంపౌండ్స్ ఉన్నాయి అనుకుందాం. ఓకే, సో ఎనీ అదర్ కాంపౌండ్ ఉన్నా దట్ ఈస్ ఆక్సిడైజ్డ్ టు రెస్పెక్టివ్ కాంపౌండ్. ఓకే, సో ఈ ప్లేస్లో ఉన్న కాంపౌండ్ ఏమంటాం, దట్ ఈస్ కాల్డ్ యాక్సెప్టర్, means which accepts the oxygen and oxidizes to its respective form. So that is called acceptor. This is activator. So a element start just to a reaction is called activator. So oxygen to combine addition compound form chestadi. So addition compound next further oxidation use అవుతుంది. That is called auto oxidator. See auto oxidator any acceptors, ఇక్కడ example H2 any acceptors తీసుకొని ఈ ఆక్సిజన్ తీసుకొని దే ఆక్సిడైజ్ their respective compound. ఇప్పుడు ఈ కాంపౌండ్ ఏమైంది, దిస్ కాంపౌండ్ ఈజ్ రెడ్యూస్డ్, మీన్స్ ఇట్ ఆల్సో హ్యావింగ్ కాన్సెప్ట్ దట్ ఈస్ రెడాక్స్ రియాక్షన్స్. బట్ ద మెయిన్ ప్రాసెస్ హియర్ ఈజ్ ఆటో ఆక్సిడేషన్ కాబట్టి, డైరెక్ట్ ఆక్సిడేషన్ కాబట్టి వీఆర్ సేయింగ్ ఇట్ ఈస్ ఆటో ఆక్సిడేషన్ రియాక్షన్స్. ఫస్ట్ we define, once again we see the other examples also. So phosphorus like non-metals and some metals like zinc, lead, and some compounds like turpentine, means that is C10H16. Okay, turpentine and unsaturated compounds and unsaturated compounds absorb water. Okay, so absorb oxygen, okay, can absorb oxygen from environment, nothing but from air, forming an addition compound which again oxidizes H2O into hydrogen peroxide. So these reactions are known as auto oxidation reactions. So mainly the total we give the importance to the conversion of H2O into H2O2 is called auto oxidation. Here one more important, so one common example can be phosphorus, some metals like zinc, lead, turpentine or unsaturated compounds is known. Here main important unsaturated, this is unknown compound for you. So unsaturated compounds ante మరి generally organic compounds లో carbon can form a single bonds with other carbons or double bonds or triple bonds. There are three choices are present for carbon. If carbon forms only single bonds around it, this is called saturated compounds. If it forms double bonds with other carbons, triple bonds and other than single bonds, double or triple, so they called as unsaturated compounds. Okay, so the conversion of H2O into H2O is called auto oxidation here. So generally the compounds initiate this reaction are called activators. What are the activators? The phosphorus, the metals, turpentine, these unsaturated compounds are activators. So they form an addition compound. So addition compound existent. So actually form an addition compound next. So other compounds ni oxidize chestadi. So that addition compound is treated as the auto oxidator. Next here, which is oxidized, H2 is oxidized, that is called acceptor. Okay, so sometimes acceptor plays low, H2 plays low, other compounds are also present. Okay. Here the reaction initiators, we say them. So the initiators, nothing but the initiators of these reactions are called as activators. So what are the activators here? Here the activators are the substances phosphorus, lead, zinc, turpentine. So very less compounds are present. So turpentine, unsaturated compounds. Like here one more important. The addition compound formed. By the activators. The addition compounds formed by the activators which oxidizes others. So are called autooxidators. They are known as autooxidators. Okay, are called activators. Autooxidators. Okay. So for example, so lead involvement प्रक्रिया form है then lead dioxide form होती. So different reactions, so different compounds form होते. Okay. Examples we see that. So already మనం lead dioxide example చూస్తున్నాం కాబట్టి we are able to write them directly. So next see what are the acceptors. So which are oxidized finally. Finally by these autooxidators. So are called acceptors. Okay. So simple ga endante, so a phosphorus e type of elements unnayi kada. So ee elements em chestante air lo undi in presence of air lo they takes oxygen and they got oxidized. So oxidized separate compound kabatti just addition compound form avutadi. So a form aina compound endante again it is oxidized compound. Ee form aina compound em chestante it oxidizes the other compound just like water. Okay, ఇక్కడ వాటర్ ని H2O లోకి ఆక్సిడైజ్ చేస్తుంది. ఓకే, సో దట్ దిస్ కన్వర్షన్ ఇస్ కాల్డ్ ఆటో ఆక్సిడేషన్ రియాక్షన్. ఓకే, ఈ యాక్సెప్టర్ ప్లేస్లో మేబీ వాటర్ ఉండొచ్చు. సో ఎయిర్ కాబట్టి కంపల్సరీ వాటర్. సో ఇక్కడ ఈ ఫామ్ అయిన హైడ్రోజన్ పెరాక్సైడ్ ఉంది కదా, జస్ట్ వి సెడ్ ద కన్వర్షన్ ఆఫ్ H2O ఇంటూ H2O2 కంపల్సరీ అవుతుంది. సో ఈ హైడ్రోజన్ పెరాక్సైడ్ ఏం చేస్తే మళ్ళీ ఇట్ ఆక్సిడైజెస్ సమ్ అదర్ కాంపౌండ్స్ ఆల్సో. ఇంకేమైనా యాక్సెప్టర్స్ ఉంటాయి కదా, సో ఆ కాంపౌండ్స్ కూడా హైడ్రోజన్ పెరాక్సైడ్ కెన్ ఆక్సిడైజ్ దెమ్ ఆల్సో. Okay, now we see the examples. So after seeing examples, you will understand it clearly. So first we see that the same example that is so lead when taken in the air, it forms an addition compound. So lead dioxide, and that lead dioxide reacts with H2O of air and forms lead monoxide and hydrogen peroxide. So here it is so already we discussed this example. So this is the initiator, that is called activator. This is auto-oxidator. This is acceptor. Okay. See one more example. Now this is an example of unsaturated compound. So the given unsaturated compound is CH3 bond CH double bond CH2. Actually this is called propene. Okay, propene when combined with oxygen forms an addition compound. So addition lo manaki so total ga form of తీసుకున్న reactants మొత్తం perfect యాడ్ అవుతాయి. ఏ సింగిల్ ఎలిమెంట్ కూడా సింగిల్ ఆటమ్ కూడా మిస్ అవ్వదు. So it forms an peroxy bond. Okay, so O single bond, O it's called peroxy bond, and this type of peroxy bond is unstable. So in presence of water, so it takes down. So you can have two oxygens free unnai kabatti, so again it becomes like this. So malla the compound form aithe this two hydrogen water molecules are oxidized to two hydrogen peroxides. Okay, here one more important, the released hydrogen peroxide, this released hydrogen peroxide, if another acceptor Ki is present anukundam. Okay, so ఇది ఈ ఎగ్జాంపుల్ రాయొచ్చు కూడా ఈ ఎగ్జాంపుల్ కూడా రాయొచ్చు. ఓకే, the formed hydrogen peroxide if combined with potassium iodide, so potassium iodide తో combined అనుకోండి, that potassium iodide is oxidized to I2. Okay, sorry, to I2, so it's a 2. Okay, here iodine is oxidized to I2, I minus 1, I2 0. Here iodide is oxidized to iodine, iodide, potassium iodide, I minus means iodide is oxidized to I2 means iodine. So here what is the oxidizing agent? Hydrogen peroxide, means this hydrogen peroxide also works as good oxidizing agent. Okay, see the one other example. So here the test is given that the formed if potassium iodide is there, so iodine is released or not. So మనం ఐడెంటిఫై చేయడానికి సో iodine కి సింపుల్ టెస్ట్ ఏంటంటే if it is passed through the starch solution, సో iodine మనం starch solution లో పాస్ చేస్తే the starch solution become light blue color లోకి కన్వర్ట్ అవుతుంది. ఓకే, that is the test for the presence of iodine. Okay, for example మనకి O2 కి ఫైర్ టెస్ట్ ఉంటుంది. O2 కి ఫైర్ టెస్ట్ అంటే సో O2 గ్యాస్ వస్తే ఫైర్ ఫ్లేమ్, సో ఫ్లేమ్ ఏమవుతుంది, ఇట్ రీలైటనింగ్ ఆఫ్ ఫ్లేమ్ టేక్స్ ప్లేస్ అండ్ ఆక్సిజన్ గ్యాస్. అదే CO2 గ్యాస్ పంపించాం అనుకోండి, H2 గ్యాస్ పంపించాం అనుకో లైట్ పైకి, సో H2 గ్యాస్ అయితే మనకు పర్ఫెక్ట్గా బర్న్ అయిపోతుంది. అదే CO2 గ్యాస్ లైట్ పై ఫ్లేమ్ పైకి పంపిస్తే వుడెన్ స్ప్లింటర్ పైకి పంపిస్తే సో ఇట్ గెట్ రిడ్ ఆఫ్. సో అట్లాగే అదైతే సింపుల్ టెస్ట్ ఉందో CO2కి ఆక్సిజన్కి, సేమ్ అయోడిన్కి సింపుల్ టెస్ట్ ఏంటంటే when this is taken into the starch solution, the starch solution become blue color. Okay, so దాంతో iodine form అయింది మనం అండర్స్టాండ్ చేయొచ్చు. Let's see one more example, that is sodium sulphite. Okay, sodium sulphite solution. Same Na2SO3, sodium sulphite solution. If taken in the air, so it automatically oxidizes and this forms an unstable acid, that is Na2SO5. Okay, it is a salt of H2SO5, salt of peroxymonosulfuric acid, salt of peroxymonosulfuric acid. Okay, so it is oxidized, but if you take Na3ASO5, Na3AS arsenite ASO3, so direct reaction does not take place. Na2SO3 in terms of air, directly it is oxidized to Na2SO5. But sodium arsenite Na3ASO3 so direct oxidation does not take place, but it is when it is mixed with the sodium sulphite. Na3ASO3, the both combinedly takes the oxygen and they are oxidized, they both are oxidized to Na3ASO4 and Na2SO4. Both compounds are oxidized. Here, which is induced oxidized means this. So actually, this original it is not oxidizing. So originally it is not oxidizing. So due to the presence of Na2SO5, so actually this Na2SO3 now forming the Na2SO5. ఈ Na2SO5 ఏం చేస్తుంటే this activates the Na3ASO3. ఈ Na3ASO3 తో మనకి యాక్టివేట్ అయిన తర్వాత ఫైనల్ రియాక్షన్ వీఆర్ రైటింగ్ అబౌట్ Na2SO3. సో యాక్చువల్లీ ఇక్కడ ఫామ్ అయ్యే కాంపౌండ్ ఏంటంటే Na2SO5 this Na2SO5 compound so combined with Na3ASO3 is an important step. See, so this now there is no separate oxygen for Na3ASO3. Okay, actually Na2SO3 combines oxygen forming Na2SO5. This Na2SO5 when combined with Na3ASO3, so now it forms Na3ASO4 and Na2SO4. Separate we are writing this equation means so for example take this first equation, this is second equation. So actually నేను డైరెక్ట్ ఫైనల్ ఈక్వేషన్ రాసిన అంటే ఈ ఇండివిజువల్ కాంపౌండ్ Na2SO3 తీసుకుంటే మనకి ఆక్సిడేషన్ అయిపోతుంది. సో Na3ASO3 సింగిల్గా మనం ఎయిర్లో ఉంచితే ఇట్ డస్ నాట్ ఆక్సిడైజ్డ్. ఓకే, సో ఇప్పుడు Na2SO5 ఫామ్ అవుతుంది. ఈ Na2SO5 ఏంటంటే ఇక్కడ ఆటో ఆక్సిడేటర్. ఈ Na2SO5 Na3ASO3లో డైరెక్ట్గా రియాక్ట్ అయిపోయి Na3ASO4 Na2SO4 ఫామ్ అవుతుంది. సో ఈ రెండు రియాక్ట్ ద ఫస్ట్ ఈక్వేషన్ సెకండ్ ఈక్వేషన్ సో కంబైన్ చేసి ఐ గివెన్ దిస్ ఫైనల్ ఈక్వేషన్. ఓకే, సో ఫస్ట్ ఈక్వేషన్ సెకండ్ ఈక్వేషన్ యాడ్ చేయండి. సో కాకపోతే మీరు ఈ సెకండ్ ఈక్వేషన్ ఇక్కడ రాయండి. సో దిస్ షుడ్ బి రిటన్ హియర్. ఓకే, Na2SO5 right left will be cancelled. Okay, remaining is Na2SO3 plus O2 Na3ASO3. So మొత్తం combine చేసేస్తాం. Okay, now first reaction second reaction is a continuous reactions. First reaction అయిన తర్వాత second reaction అవుతుంది. So overall reaction నేను balance చేసేసి I given the final equation. Here this is the activator, this is auto oxidator, this is acceptor, this is activator, auto oxidator, this is acceptor. Okay, so now we see other type of reactions. So in the last session we discussed about disproportionation reactions. So what are disproportionation reaction? You remember it? So the reaction in which the same element undergoes oxidation and reduction. The reactions in which same element, the redox reactions in which same element undergoes oxidation and also reduction are called disproportionation reactions. So same type of reactions but exactly reverse. Okay, so ఇంతకుముందు మనకి స్టార్టింగ్లో తీసుకున్న ఎలిమెంట్ ఎక్స్ తీసుకుందాం. So now we are discussing actually about comproportionation reactions. So comproportionation reactions. So comproportional reactions, they are exactly reciprocal. They are exactly reciprocal to the disproportionation reaction. So disproportional reactions, so what we discussed there. That for example X element తీసుకుంటే X oxidation number +1 అనుకుందాం. So it forms two different compounds. Okay, this మనం ఏదైతే చేంజ్ అవుతుందో ఆ ఎలిమెంట్ గురించి డిస్కస్ చేస్తున్నాం. X +1 0 అయింది అనుకుందాం +2. Here X is reduced as its oxidation number decreased, called reduced, and from here to here X is oxidized as its oxidation number increased, it is oxidation number. So the same element oxidized and reduced. In products it is having two oxidation states, in reactant it is having one oxidation state. So exactly the reverse reaction ఏమంటే comproportionation reactions అంటాం. So exactly reverse means Here also element, same element oxidized and same element reduced, but in the reactants two oxidation states are present. So for example, take x plus 1, sorry, x plus 1, so it is becomes so plus 2, so it is oxidized. So other x, same element present in the plus 3 oxidation state. Now what about this? The same element is reduced. So ఇంతకుముందు రియాక్షన్స్ లో కూడా సేమ్ ఎలిమెంట్ ఆక్సిడైజర్ రెడ్యూస్డ్, కాకపోతే ప్రోడక్ట్ రియాక్టెంట్స్ లో 1 ఆక్సిడేషన్ స్టేట్ ఉంది, ప్రోడక్ట్లో 2 ఆక్సిడేషన్ స్టేట్స్ ఉన్నాయి. ఇంక్రీజ్ డిక్రీజ్ మొత్తం ప్రోడక్ట్ సైడ్ అయింది. ఇక్కడ మనకి రియాక్టెంట్స్లోనే 2 టైప్ ఆఫ్ ఆక్సిడేషన్ స్టేట్స్ ఉంటాయి, ప్రోడక్ట్స్లో ఓన్లీ 1 టైప్ ఆఫ్ ఆక్సిడేషన్ నెంబర్ ఉంటుంది. సో టోటల్గా అదే ఎలిమెంట్ ఆక్సిడేషన్ అవుతుంది, అదే ఎలిమెంట్ రెడ్యూస్ అవుతుంది, బట్ ఎగ్జాక్ట్లీ రివర్స్ రియాక్షన్స్ టు దట్ disproportionation reactions. Okay, so we can write these reactions. So mainly actually మనకి disproportionations are very important here. First we can, these are exactly reverse. Okay, these are exactly reversed reactions to the disproportionation reactions. Next we can write in these reactions at reactants, okay, at reactants so the single element, okay, the element shows two different oxidation states and one oxidation state in products. Okay, or we can write the reactions in which the reactants, at reactants a single element shows two different oxidation states and one oxidation state in products are called comproportionation reactions. Okay, means the, let's see the example. Actually it takes the presence of acidic medium. So this is the best example for this. Here take bromide, Br minus, so Br2, what is this change? -120, it is oxidized. Okay, nothing but it is oxidation reaction. That's what about this change? BrO3 minus becomes BrO2. So what is the BrO3 oxidation number? BrO3 minus low. What is the Br oxidation number? X minus 6, so -1, so x equal 5. Okay, so here Br plus 5, so plus 5 to 0 means it is decrease. It means it is a reduction. Mean the same element, bromine in the reactant present in the two oxidation state, -1 and +5. In the products it is having only one oxidation state, that is 0. So these are exactly reverse to the disproportionation reactions, or called comproportionation reactions. Okay, now we see other type of reactions. This is total different classification, that is intermolecular redox reactions. Intermolecular redox reactions. So intermolecular redox reactions, they are not a big important type. So any types based cheskoni they given the reactions. So actually, so these are the redox reactions. So intermolecular redox reactions and so manaki already just redox reaction means reduction takes place, oxidation takes place, no doubt in it. But in there is intermolecular redox reactions in the atoms belong, the elements belongs to different molecules. Different molecules undergoes reduction and oxidation. Same element or different element or whatever it is. Okay, same element kaవచ్చు, different element kaవచ్చు, but that element must be present in two different molecules. The element must be present in two different molecules ఉన్న element so oxidation అవ్వాలి, reduction అవ్వాలి. అది same element కావచ్చు or different elements కావచ్చు. Okay, so means we can write so the redox reactions, we can write the definition as so the redox reactions so in which one molecule is oxidized and another is reduced, so are called intermolecular redox reactions. So ఇప్పుడు ఆ కాంపౌండ్ లో ఉన్న సేమ్ ఎలిమెంట్ ఆ డిఫరెంట్ ఎలిమెంట్ దట్ ఈస్ డిఫరెంట్ థింగ్. ఓకే, the redox reactions in which one molecule is oxidized and another molecule is reduced, and minimum there is a two reactants unali. Okay, minimum two reactants unali. If you see the examples, so NO3 minus plus, just we have to remember the example, no need to by heart these examples. So giving NH4 plus HS4 minus, so just tell just say which is oxidized and which is reduced. What is the sulfur oxidation number here? S minus 2. So what is the sulfur oxidation here? 1 minus 8, this is plus 6. Okay, the sulfur is plus 6. S minus 2 to this is oxidized. Means H2S is oxidized. H2S is oxidized to HS4 minus. కాబట్టి దీంట్లో ఏ ఎలిమెంట్ ఇన్వాల్వ్ అయిందంటే సల్ఫర్. ఓకే, సో సల్ఫర్ ఇన్వాల్వ్ మన టోటల్ కాంపౌండ్ అని చెప్పొచ్చు. సల్ఫర్ oxidized అనొచ్చు, or we can say H2S is oxidized to HS4 minus. And what about the nitrogen oxidation state here? NO3 minus here X minus 6 minus 1 means X equal 5. So nitrogen 5. What is the nitrogen here oxidation state? H plus 4 is equal to 1. Is equal to, sorry, what is the oxidation number of nitrogen you got? So X equal to this minus 3. So here plus 5 to minus 3. So it is reduction and oxidation. But this is a total. Nitrogen belongs to one molecule. This belongs to another molecule. Two molecules involved by undali. Simple. That is called intermolecular redox reactions. Disproportionation, comproportionation, substitution, sorry, decomposition or displacement. So it is not the matter. That is total separate classification. Okay. So దీంట్లో ఏ రియాక్షన్ అని ఉండొచ్చు మనకి. జస్ట్ ఇంటర్ అండ్ వన్ మోర్ ఈజ్ ఇంట్రామోలిక్యులర్ is there. So we see one more example for this. So iron when compared with hydrogen, okay, N2H4 is called hydrogen forming ammonia, and FeOH taken to the presence of air takes place. So in the presence of acidic medium it takes place in the presence of air. Okay, so this here nitrogen, here what is the nitrogen oxidation number? Here iron Okay, first check the nitrogen. 2x plus 2 equals 0. Here it is minus 1. Is it correct? 2x plus 2 is 2. Oh god, here what is the oxidation state of nitrogen? That is minus 3. Minus 1, 2, minus 3. So it's a reduction, okay? Write the sentence. That is reduction. Here iron 0. Whatever I had OH, always we said OH means minus. So OH ki combine mana minus right. Just like SO4 minus 2. X minus 2 equals 0. X equal to 2 plus 2. So 0 to plus 2 means it is oxidized. So one molecule is oxidized, one molecule is reduced. Okay, this is intermolecular redox reaction. Let's see one more important example. So the potassium iodide, potassium iodate reacting with the hydrochloric acid forming plus 3H2. Okay. So here, see this example, the potassium no change. See the iodine is I minus 1, here I2 is 0. So iodide is oxidized to I2. So it is oxidation. What about here? Here iodine oxidation. So hydrogen same, Cl will be same, oxygen will be same, potassium will be same. So we compare cheyalem. Potassium plus 1 plus 1, Cl minus 1 minus 1, hydrogen plus 1 plus 1, O minus 2 O minus 2, no comparison. So compare chese charge మనకు only IK ఉంది ఇక్కడ. So ఇక్కడ what is the iodine oxidation state? Sorry, that is 1 plus X. So minus 6 equals 0. So X equals 5. So iodine oxidation number 5. Here it is changed from plus 5 to 0. It is reduced. So as in the starting segment, starting లో చెప్పుకున్నాం. So same element oxidation reduction అవుతుందా, different element అవుతుందా? So that is not the matter. So కాకపోతే that elements must be belong to different molecule. Okay, మన product లో ఉన్నా it is not a matter. So reactant లో 2 different molecules ఉండాలి. ఒకటి oxidation లో ఇన్వాల్వ్ అవ్వాలి, ఒకటి reduction లో ఇన్వాల్వ్ అవ్వాలి. It may be same element or different element. Okay, so these are called intermolecular redox reactions. Now we see the one more, the last classification, intramolecular. So this is IN, okay. Intramolecular redox reactions. So in this reaction, only one molecule is oxidized and reduced. So these are the redox reactions. In which only one molecule is oxidized and also reduced. So are called intramolecular redox reactions. Means here only one type of reactants are present. If you the examples, that is ammonium nitrite, okay, NH4 NO2 on its decomposition, so it forms N2 plus 2H2. Here you see the only the nitrogen is oxidized and nitrogen is reduced. So actually in this calculation of this NH4 NO2 we do in terms of ionic compound, that is NH4 plus NO2 minus the separate compounds. Okay, here what is X? What is here? So here nitrogen oxidation state 3 minus 3. So here it is 0. Means that the only single reactant is present, it is oxidized. So if you compare and go to the here to here, it is 3 to 0 reduced. So minus 3 to 0, it is oxidized. So this type of reactions in which only one of the reactants, more reactants now participated only one reactant. So one of the reactants undergoes oxidation and also reduction. So either oxidation, either reduction, you have to write it, okay? Are called intramolecular redox reactions. So very rare reactions involve this type of reactions. Okay, see this. So here we can combine what here. What is the manganese oxidation number? So manganese oxidation number is what? I mean to this 2x minus 14 equals 0. So here 2 manganeses are present. I mean to go 7. Actually it should be ion, okay, because we are getting the fractional values, okay. 2x equals 14. So each of manganese having plus 7. Here manganese oxidation number is x plus so here whatever the manganese plus 7 to plus 4, it is reduced. Mean here manganese is reduced from the 7 to plus 4. Now check the what is oxygen. So oxygen oxidation already we took, it is a minus 2. ఇక్కడ peroxy bond లేదు, we have to remember. So దీంట్లో peroxy bond లేదు మనకి. So ఇక్కడ O2. So what is this change? Minus 2 to 0. It's increased. So it's oxidation. So one of the reactants, only one of the reactants undergoes oxidation and reduction. So already we said oxidation reduction involve the same element or different element, it doesn't matter. So two different reactants unte, that is intermolecular. Intramolecular only one of the reactants, okay. దాంట్లో సేమ్ ఎలిమెంట్ ఆక్సిడేషన్ రిడక్షన్ అవ్వచ్చు, డిఫరెంట్ ఎలిమెంట్ ఆక్సిడేషన్ రిడక్షన్ అవ్వచ్చు, ఓకే. We see the last example. Okay, already we know this is the decomposition of potassium chlorate. So what is the purpose of this reaction and what is the main importance of this reaction? It is a decomposition redox reaction. It is used to prepare the oxygen, okay, to prepare the oxygen artificially. This reaction is used. So here see the potassium. So potassium plus 1, it's no change in it. So what about chlorine? Here chlorine simply minus 1, oxygen 0. So 1 plus x. We are calculating Cl. Oxygen ke alag minus 2 kada. X equal 5. So potassium plus 1, there is no need to consider it. So plus 5 minus 1. So plus 5 to minus 1, it is reduction. Chlorine is reduced from plus 5 to minus 1. What about oxygen? So oxygen already minus 2. So minus 2 to it becomes 0. So minus 2 to it becomes 0 means it is oxidized. So write the oxidation and reduction steps. Okay. So these are called intramolecular redox reactions. So these are the types of redox reactions. So మనం స్టార్టింగ్లో డిస్కస్ చేసిన కాంబినేషన్, డీకంపోజిషన్, డిస్ప్రపోర్షనేషన్, కంప్రపోర్షనేషన్, నెక్స్ట్ displacement reactions, avandi one type of classification. Intermolecular is it's a separate type of classification, okay. So totally, so we completed the types of redox reactions, okay. So tomorrow we do some calculations based on redox reactions, okay.